Hello and welcome to another short video for the CAD2 module. In this exercise we're going to model this memo block part here. It's a fairly simple part, just using a couple of extrusions and extruded cut features. But what I want to do is use this simple example to start to introduce the idea of variables and equations. So if you look at the notes up here in the top corner, it says that we want to model this in such a way that all the dimensions of the memo block, or the external dimensions rather, are in the form of a cube. So B is equal to D is equal to H. The breadth is equal to the depth is equal to the height. The wall thickness is a constant 2 millimeters throughout, and there's a hexagonal cut running through the part, and the hexagonal dimension between flats is going to be half of the cube dimension. So if the cube is 60, the hexagon will be 30. But if we modify that later so that the cube dimension is say 50, we want this to automatically update to 25. Okay, so I've gone ahead and created a new part file and saved it into its own folder. And what I'm going to do is create a new sketch on the top plane, and we'll do most of the extrusions from one shared sketch. So I'll create a new sketch on the top plane, and I'm going to just rough out the shape of the plan of this part. So it's going to be roughly a square. And then if I use the line tool, I can just draw a couple of lines here like so. Now what I want to do is I'm going to draw that line directly to the midpoint of that top line of the rectangle here. I'll do the same down the bottom, maybe I'll be a little bit more obvious about it. So if I hover my mouse here, I can, SolidWorks will infer an automatic coincident relation to the midpoint here. So I'll start that line, come up a little bit, across and up to the top, coincident with the top. Okay, so that's the rough shape of the plan view of the memo block. Now by putting these lines here coincident with the midpoint, see what happens is as I change the dimensions of this here, it'll stay sort of symmetric, or rather I suppose it will when I've finished dimensioning it. But these two lines here, which represent the front and back wall of the memo block here, they're going to stay coincident with the midpoint of that face. Okay. So the basic idea is that we're going to use this sketch here as a shared sketch, and we can create multiple extrusions from it of the various sketch regions within here. So we can have one extrusion based on these two regions to create the walls, and we can have a separate extrusion based on the middle region here to create the base of the part. Okay, now I'll go back into my sketch and make sure I have it fully defined before I go ahead and do that. And I'll just rotate my sketch so that I'm looking in normal 2. Okay, so I want this base to be 60 by 60, and I want to extrude up those walls to be a height of 60 as well. Now I could, in order to do that, I could use separate dimensions here. So I could dimension this one 60 rather, and I could do a separate dimension on the top of the square here to make that 60. Okay, now that would work, but if I go to modify this part later, as I said, and make it 50 by 50, I'd have to come back and change 2 dimensions here for that, and I'd also have to change the height of the extrusions as well manually. So instead, what I want to do today is to start looking at equations and variables, as I said. So maybe what I'll do first is I'll put in one dimension here of 60 on that and just demonstrate a couple of different ways to go about this. So that dimension of 60, when I put it in, if I double click onto that dimension, I should be able to go back here. That dimension has a name. It has a variable. Excuse me, go back into it again. If I double click into it again, you'll see that dimension is called D1 at sketch 1. So it's the first dimension that I put in on sketch 1, and it has a value of 60. Okay. When I put in another dimension on the top of the square here, for example, rather than typing in a value, here, I can put in an equation. So if I started with if I start my dimension with an equal sign, it's going to become an equation. So I can say equals to, and type in what was it, D1 at sketch 1. And what that'll do, excuse me, so it's D1 at sketch 1 and it's in quotation marks. What that'll do is it'll set this dimension, the value of this dimension, equal to whatever was in this dimension here in D1 at sketch 1. So that's one way to do it. Alternatively, I could just say equals and click on that dimension over there, and it'll automatically put in the equals D1 at sketch 1 for me. Okay. And if I click OK now, you'll see this value up here is now has a little summation sign beside it, a sigma. And what that means is that this value here is calculated. So it's calculated to a value of 60. So let's say, for example, I come over here and I change that to 50 and rebuild. A little bit of lag there. But if I change this value to 50, the one up here gets calculated to 50 to match. Okay, so that's one way of doing it. You can use the inbuilt names of those dimensions, like D1 at sketch 1 and D2 at sketch 2. There is another way to do it that maybe in this particular case might make sense, because that's all well and good if you're within the one sketch and you can just maybe I can, as I said, I can click on an existing dimension to put that in. But if I'm in a different sketch somewhere else in the part, it can become a little bit cumbersome to type in D1 at sketch 1. So what I can do is I can create a variable, just create a symbol, a letter or something like that, to represent the dimension of the cube. So what I'll do is I'll go in here, I'm just going to change that value back to 60. Oops. I'm going to change that value back to 60 as it was before. Go back into my dimension. And here, instead of typing in a value, a number, a numerical value, what I can do is I can type in a letter. So say, for example, the letter X or the letter D or whatever. So when I type in a letter here, it pops up with a little option above there with the option to create a global variable. So it's just going to create a variable called D, the letter D. Global means that that variable will be available anywhere throughout my part file, not just in this sketch here, for example. So if I click on that, click Create Global Variable, it has created a variable called D, which has a value of 60 at the moment. Okay? Okay. Now if I go to add a dimension somewhere else, so let's say if I go to add a dimension to the top of this square here, what I can do now is rather than typing in a numerical value or rather than typing in D1 at sketch 1, what I can do is I can just say equals the global variable equals the global variable. Now this is not displaying properly for me. I should be able to just say equals D. Okay, I'm not sure quite what happened there. Equals D. I can just type it in anyway, equals D, and highlight my global variable here. And again, that will calculate the value that this dimension should have to be whatever that global variable happens to be. Okay, so I can do something similar for the wall thickness here. At the moment, these are not defined. But if I put in a dimension, let's say I'll put in one dimension on this wall thickness over here, for example. So I'll dimension between these two lines, and I'll set that equal to 2 as an initial value. Okay. Now if I go back into that again, rather than leaving it as a numerical value of 2, what I'll do is I'll say, I'll just type the value t, lowercase t, for the wall thickness. And I get the little option above here to create a global variable. Okay, so I've created a global variable that has an initial value of 2. Okay. Now, just to show you, over here in the feature tree on the left hand side, we have this new folder here, this new section called equations. And within that, we have our 2 global variables that I've created, one of them called D and one of them called T, which has a value of 2. Okay, so now when it comes to dimensioning the rest of the wall thicknesses here, I could use, rather than typing in a numerical value of 2, I can just use the global variable T for those wall thicknesses. So I'll do that. I'll put a dimension, say here on this side, between here and here. Or this is one way to do it. I can put a dimension there between here and here. And rather than typing in a value of 2, what I'll do is I'll type in equals T and select my global variable T here. Okay. Likewise, I can put a dimension on, say, between the flats here, or on this little line. I can put a dimension here and let that equal to T. Equals T. And I could do the same down at the bottom, or I can use a combination of dimensions and sketch relations. So for example, rather than dimensioning the bottom one, what I can do is pick this line, hold Control and select this line down here, and make those 2 lines equal in length. Okay, and that fully defines my sketch now. I could have done something similar. I could have set this line here equal in length to this line up here, and that would have removed the need to put in probably this dimension over here. In any case, my sketch is now fully defined, so I'm going to exit out of that. Okay, so that's my 2D sketch. It's going to be shared between a couple of different extrusion features. I can highlight sketch 1, create an extruded feature, extruded boss base feature here, and I'll highlight the 2 areas enclosing what will be the walls, and I'm just going to extrude those blind by a distance here. Now I want that distance to be 60, but again, rather than typing in a numerical value of 60, what I can do is type in equals global variables, and usually you should be able to see that in a little drop down menu. For some reason it's not displaying properly, maybe the screen recording. So instead I'll just type in equals D and select my global variable here. Okay, and when I hit the check mark there, it evaluated that to 60. You can flick over and back between the showing the global variable or showing the calculated value for that. That little button there. Alright, so click OK. That should now have generated that has generated the walls. I can expand out this again, highlight sketch 1, and use sketch 1 now to create a second extrusion. Okay, again I want to go from the sketch plane, I want to go blind. This time I just want to extrude this middle section, and I only want to extrude it a height of 2. But again, rather than selecting the height of 2 here, I'm going to set that equal to my global variable of t. And that evaluates to 2. Okay, so that's the kind of basic shape of the memo block there. The advantage of doing it this way, as I said, is that you have these variables. I could come along later, change these variables to 50 and 1.5, or change it to 90 and 3, or whatever values I want, and it should rebuild my model then to that size just by changing 2 numbers. Okay, the next step here would be to do the hexagon, and the hexagon is going on the large face here, and it's going to cut through both walls. Okay, so I'm going to create a new sketch on that face. So I can highlight that face, create a new sketch, and I will rotate around to look in normal to my sketch. The origin is down here, but that doesn't strictly matter. So I'm going to use the polygon tool up here at the top to create the hexagon. You can create a polygon with various numbers of sides. For a hexagon we want 6 sides, and you can choose whether you want it to be generated off an inscribed circle or circumscribed circle. So what that means is if you create the hexagon, inscribed circle means it has a circle inside the flats of the hexagon, and circumscribed would be a circle outside the flats, so going through the points or the vertices of the hexagon. So we want an inscribed circle here. We're going to dimension between the flats of the hexagon. So that's created a 6-sided polygon for us. We can move the location of that around to wherever we want on the sketch. Now what I want is I want that to be centered on the face of the memo block here. Again, there's a few ways you could do that. Probably the simplest way here is to create a center line. You could go across the diagonals, or you could go from midpoint to midpoint. It doesn't really matter in this case. So this center line is going to be a construction line. It's not going to form part of the extrude cut feature later. I could create 2 center lines and move the location to the intersection of them, or I can create 1 center line, move the location of my hexagon to the midpoint of that line. Okay, so drag and drop it, or I can highlight the center, control click on the midpoint over here, and make those 2 points coincident. Okay, so that locates the center of the hexagon in space. It's still free to rotate, and it's still free to change size. So I can dimension between the flats, for example. Here should be nominally it's 30, but really what that is it's half the dimension of the cube, so half of my global variable t. So this is where equations comes into it. I can, again, rather than putting a numerical value, I can say equals the global variable, which again is not shown up from here, but I'll say equals d, the global variable of d, divided by 2, or I can say multiplied by 0.5. Okay, so that'll take whatever the value of d is, in this case it's 60, by 0.5, and that should calculate to 30. I can toggle between the views here, so I can see my equation, or I can see the result of that equation. Okay, so that's the dimension between flats for the hexagon. It's still free to rotate around. Now I do just want to check, and I think the orientation of it should actually be this way, so that the flats are at the top and bottom of the hexagon. So what I can do there is I can put in just a simple relation on one of these flats to say that it should be a horizontal line. And that now has fully defined, my sketch. Okay, so if I close out that sketch, I can use that sketch then to create a cut extrude feature, or an extruded cut feature here. And what that's going to do is it's going to extrude perpendicularly inwards from the sketch plane. At the moment it's going blind by a certain distance, but what I'll do is I'll change it so it's going through all. That should cut through both walls of the memo block. Okay, and that's almost it. We've one last thing to do, and that's just to put some fillets on these corners here. And I believe, let me just check that now. Yes, so there's fillets on all 4 of those corners at the top. Okay, so just use the fillet feature here in the Features tab. And we have the items to fillet. So we have a constant radius fillet. The items to fillet will be this corner. Radius 5, I think. This corner. This corner. Here and here. Yeah. Okay, and that, I believe, is the part finished. Okay, so this video's gone on a bit longer than I thought, but thanks for watching.